In this video, we're going to solve several dosage calculation problems related to time of infusion. Here's our first problem. Infuse 800 milliliters of D5W at a rate of 100 milliliters an hour. How long will the infusion last? We're going to solve this problem using DKP method. What do we know from this problem already? We know that 100 milliliters are going over 1 hour. 100 milliliters is 1 hour. I need to infuse 800 milliliters. I'm going to put milliliters under milliliters and say that 800 milliliters is X hours. Now I'm going to find a diagonal that's not an X and multiply these two numbers and divide by the third number. $800 times 1 divided by 100. And that equals to 8 hours will take us to infuse these 800 milliliters of D5W. This problem is very similar to the first one. However, there's more instructions about how to round and how to represent our answer. So infuse 750 milliliters of LR at 90 milliliters an hour. How long will the infusion last? And here's the difference. Round to the nearest tenth and then give your answer in hours and minutes. How do we do that? Just like in the first problem, let's first find what amount of time it will take us to infuse these milliliters of LR. And we say 90 milliliters is going over 1 hour. 750 milliliters. We don't know how many hours. We multiply on diagonal, divide by the third number, carefully checking, do we have my hours under hours, milliliters under milliliters? Yes. So 750 times 1 divided by 90 will give me the amount of time it will take to infuse 750. 8.333 repeated hours. How do we represent it as hours and minutes? Because 0.333 is not the same as to say 333 minutes, right? So 8 hours, good to go, but minutes we need to convert properly from a decimal of an hour to minutes. And the instructions say round to the nearest tenth first. So let's go ahead and do that. After rounding, 8.333 repeated is just 8.3 hours. Now, to go to minutes, we leave hours alone. We only work with this 0.3 of an hour, okay? And we just multiply it by 60 because there are 60 minutes in an hour. .3 times 60 is 18 minutes. So our answer here is 8 hours and 18 minutes. Our infusion will last. Now remember, when you're converting these decimal of an hour to minutes, first of all, don't be confused thinking that this is 30 minutes, 0.3. Sometimes students make mistake like that. And second of all, when you're converting by multiplying by 60, don't involve your hours. Hours, they're good to go, right? If you start to multiply 8.3 by 60, you're going to get enormous number of minutes because you're going to calculate minutes in the 8 hours and the 0.3 of an hour, right? So leave your hours alone, only work with the decimal part of an hour to convert it to minutes by multiplying by 60. Here's our next problem. LR is infusing at 125 milliliters an hour. The 1000 milliliter bag was started 2 hours ago. It is 0300 now. What time will the infusion be complete? Let's first, in order to answer this question, let's first find how many hours it will take for our infusion to be complete, and then we can answer this question. Just like before in the previous two problems, we say that 125 milliliters are going to 1 hour. If I need to infuse 1000 milliliters, How many hours will it take me? Multiply on diagonal, divide by the third number. 1,000 times 1 divided by 125 equals 8 hours. But that's not it, right? Because it's not asking us how many hours it will take for the infusion to be complete, but at what time it will be complete. Let's see. It's 3 o'clock now, but the infusion started 2 hours ago. That means it started at 1 o'clock a.m. From 1 o'clock a.m., we're counting 8 hours. And I always recommend counting hours on your fingers. You're least likely to make a mistake when you count on your fingers. So from 1 o'clock, counting 8, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be 9 o'clock. 0900. That's your answer. In this problem, the order is to infuse 1,000 milliliters normal saline at 75 milliliters an hour. What volume to be infused will the nurse program into the pump in order to stop the infusion 30 minutes before the bag is completely empty? And we're going to be rounding to a whole number. What does it all mean? Imagine a bag of normal saline. You don't want to infuse the entire bag. You want to keep some amount on the bottom and you want to infuse the rest. Okay? And the amount you want to keep on the bottom is 30 minutes worth of fluid. So let's find first what is 30 minutes worth of fluid. If 75 milliliters are going over an hour, what is it per 30 minutes? And if it's intuitive for you and you see that you just divide this by 2, that's great. If it's not intuitive for you, set it up as DKP. I'm going to put 75 milliliters is 60 minutes. I need to find for 30 minutes. How many milliliters is for 30 minutes? $75 times 30 divided by 60. And that equals to 37.5 milliliters. This is how many milliliters I want to keep in a bag and infuse the rest. What's the rest? 1,000 milliliters minus what I want to keep. And I get 962.5 milliliters. I'm instructed to round to the whole number. And my answer is 963 milliliters. I will program the pump to infuse. So when you're programming the pump, not only you put the rate, like we talked about, milliliters an hour rate that you want the pump to be infusing your medication or your fluid, but you also need to tell the pump how much is it that you want the pump to infuse, right? And it's called volume to be infused. When you work with the pump, that's what you will be looking for. And in this case, it's 963 milliliters will infuse, and we will hold 37.5 in the bag. What is the reason we would want to keep certain amount in a bag? Why would we want to do that? Could be several reasons. For example, if you are infusing 1,000 milliliters and then the doctor says we're going to make it a continuous infusion, continue putting the bags up, okay? We're going to keep infusing the patient. So you infuse this bag, you need to hang the next bag. And to hang the next bag, you usually can use the same tubing from the old bag. However, if the entire bag infused and everything is empty, then you have to spend time priming the tubing again for the new bag. So in order not to do that, you want to keep certain amount in the bag, an old bag, so that you can take the tubing from the old bag, spike the new bag, and not have to prime the tubing. And this is our last time related problem for today. A nurse is caring for a patient who had IV fluids initiated at 3:30 at a rate of 120 milliliters an hour, how many milliliters will the nurse record as an intake for this patient at 6 o'clock in the morning? How do we start this problem? First, let's figure out how much time passed from 3:30 when fluid was initiated to 6 o'clock when we want to calculate the intake. I always tell you to count your hours on your fingers, right? From 3:30, 4:30, 5:30, and a half to get to 6. So 2.5 hours passed, right? Now, every hour patient is receiving 120 milliliters. So 120 milliliters is 1 hour. We're doing DKP method again. We need to find per 2.5 hours. 1 hour, 120 milliliters, 2.5 hours. I don't know how many milliliters. Multiply on diagonal, divide by the third number. And the answer is 300 milliliters. The nurse will document. In the comments below, let me know what other dosage calculation problems you want to solve together. And you will find more practice problems like these in my book, Dosage Calculations, Getting It Right Every Time.